Assalamualaikum. My name is Muhammad Haikal Rafiq bin Muhammad Haizat, metric number S50702, Faculty of Ocean Engineering Technology and Informatics. Subject is Ship Maintenance and Repair System MM33203. Today, we're gonna talk about 4 methods of non-destructive testing, or in shortcut NDT. There is 4 methods of non-destructive testing, which is dye penetrant testing, magnetic particle testing, radiographic testing, and ultrasonic testing. Okay, first, what is dye penetrant testing? Dye penetrant testing is based upon capillary action, where low surface tension fluid penetrates into clean and dry surface, breaking discontinuities. Penetrant may be applied to the test component by dipping, spraying, or brushing. After adequate penetrant time has been allowed, the excess penetrant is removed. Developer is applied. Developer helps to draw penetrant out of the floor where an invisible indication becomes visible to the inspector. Okay, work procedure for dye penetrant testing. First, pre-cleaning. The test surface is cleaned to remove any dirt, paint, oil, grease, or any loose scale that could either keep penetrant out of a defect or cause irrelevant or false indications. Second, a ideal cleaned test piece. Third, application of penetrant. The penetrant is then applied to the surface of the item being tested. The penetrant is allowed dwell time to soak into any flaws, generally 5 to 30 minutes. Then, excess penetrant removal. The excess penetrant is then removed from the surface. The remove method is controlled by the type of penetrant used: water washable, solvent removal, lipophilic post-emulsifiable, or hydrophilic post-emulsifiable. Then, application of the developer. After excess penetrant has been removed, a white developer is applied to the sample. Several developer types are available, including non-aqueous, wet developer, dry powder, water suspendable, and water soluble. Then, the inspection. The inspector will use visible light with adequate intensity for visible dye penetrant. Ultraviolet UAVA radiation or adequate intensity micro per centimeter square is common, along with low emission light levels. For fluorescent penetrant examination, inspection of the test surface should take place after 10 to 3 minute development time, depend of product kind. The test surface is often cleaned after inspection and record of defect, especially if post-inspection coating process after schedule. Advantage and disadvantage. Advantage: high sensitivity, small discontinuities can be detected. Few material limitation: metallic and non-metallic, magnetic and non-magnetic, and conductive and non-conductive material may be inspected. Rapid inspection of large area and volumes, suitable for parts with complex shapes. Indications are produced directly on the surface of the part of constitution a visual representation of the floor. Portable material are available in aerosol spray cans. Low-cost material and associated equipment are relatively inexpensive. Disadvantage: only surface breaking defection can be detected. Only material with relative non-porous surface can be inspected. Poor cleaning is critical, then contaminants must detect. Metal smearing from machine grinding and grade of vapor blasting must be removed. The inspector must have direct access to the surface being inspected. Surface finish and rough can affect the inspection sensitivity. Multiple process operation must be performed and controlled. Post-cleaning of accessible part of material is required. Chemical handling and proper disposal is required. Next, magnetic particle testing. Magnetic particle inspection is a non-destructive testing process for detecting surface and shallow subsurface discontinuities in ferromagnetic materials such as iron, nickel, cobalt, and some other alloys. The process puts a magnetic field into the part. The piece can be magnetized by direct or indirect magnetization. Direct magnetization occurs when the electric current is passed through the test object and a magnetic field is formed in the material. Indirect magnetization occurs when no electric current is passed through the test object but a magnetic field is applied from an outside source. The magnetic lines of force are perpendicular to the direction of the electric current, which may be either alternating current AC or some form of direct current DC. The presence of surface or subsurface discontinuity in the material allows the magnetic flux to leak, since air cannot support as much magnetic field per unit volume as metal. To identify a leak, various particles either dry or in wet suspensions are applied to a part. They are attracted to an area of flux leakage and form what is known as indication, which is evaluated to determine its nature, cause and course of action. Work procedure. First, induce a magnetic field in the specimen, then apply the magnetic particle to the specimen surface which is dry or in liquid. Then view the surface looking for particle groupings that are caused by the defects, and then demagnetize and clean the specimens. Advantage and disadvantage. Advantage: can find both surface and near subsurface defects. Some inspection formats are extremely portable and low cost. Rapid inspection will immediately result. Indications are visible to the inspector directly on the specimen surface. Can detect defects that have been smeared over. Can inspect parts with irregular shapes. Disadvantage: the specimen must be ferromagnetic. Examples such as steel and cast iron. Paint thicker that about 0.005 must be removed before inspection. Post-cleaning, any post-demagnetization is often necessary. Maximum depth sensitivity is typically quoted as 0.100, deeper under perfect conditions. Alignment between magnetic flux and defects is important. Next is radiographic testing. Industrial radiography use either X-ray produced with X-ray generator or gamma rays generated by the natural radioactive or sealed radionuclide source. After closing the specimen, photons are captured by a detector such as silver halide film, a phosphor plate flat panel detector or CDTE detector. The examination can be performed in static 2D, in real-time 2D fluoroscopy, or in 3D after image reconstruction, computed tomography or CT. It is also possible to perform tomography nearly in real time, 4-dimensional computed tomography or 4D CT. Particular techniques such as X-ray fluorescence XRF, X-ray diffractometry SRD, and several other ones complete the range of other tools that can be used in industrial radiography. Work procedure. The method is based on the same principle as medical radiography in a hospital. A piece of radiographic film is placed on the remote side of the material under inspection, and radiation is then transmitted from one side of the material to the remote side where the radiographic film is placed. The radiographic film detects the radiation and measures the various quantities of radiation received over the entire surface of the film. This film is then processed under the dark room condition, and various degrees of radiation received by the film are imaged by the display of different degrees of black and white. It is termed the film density and is viewed on a special light emitted device. Discontinuity in the material affects the amount of radiation being received by the film through the particle plane of the material. Qualified inspector can interpret the result image and record the location and type of defect present in the material. Radiography can be used on most material and product form. Radiographic testing provides a permanent record in the form of radiograph and provide a highly sensitive image of the internal structure of the material. The amount of energy absorbed by the object depends on its thickness and density. And energy not absorbed by the object causes exposure of the radiographic film. This area will be dark when the film is developed. Area of the film exposed to less energy remain lighter. Therefore, areas of the object when the thickness have been changed by discontinuities such as porosity or cracks will appear as dark outlines on the film. Inclusion of low density such as slag will appear as dark areas on the film, while inclusion of high density such as tungsten will appear as light areas. Advantage and disadvantage. Advantage: volumetric inspections, permanent record, good quality control method can detect surface and subsurface flaw. For the disadvantages, gamma result inferior to X-ray result, radiation to hazard, equipment can be bulky and heavy, may not detect critical flow, and access may be required to both sides of object. Ultrasonic testing. Ultrasonic non-destructive testing, also known as ultrasonic NDT or simply UT, is a method of characterizing the thickness of internal structure of a test bed through the use of high frequency sound wave. The frequency of pitch used for ultrasonic testing are many times higher than the limit of human hearing, most commonly in the range for 500 kHz to 20 MHz. High frequency sound waves are very directional and they will travel to a medium like a piece of steel or plastic until they encounter a boundary with another medium like air, at which point they reflect back to the source. By analyzing the reflection, it is possible to measure the thickness of test piece of fine evidence or crack of the hidden internal flaw. In ultrasonic testing, an ultrasound transducer connected to a diagnostic machine is passed over the object being inspected. The transducer is typically separated from the test object by a component such as oil or by water as emission testing. Work procedure. There are two methods of receiving the ultrasound waveform: reflection and attenuation. In reflection or pulse echo mode, the transducer performs both the send and receiving of the pulse wave as the sound is reflected back to the device. Reflected ultrasound comes from interface such as the back wall of the object or from an imperfection with the object. The diagnostic machine displays the result in the form of signal with an amplitude representing the intensity of the reflection of the distance representing the arrival time of the reflection. In attenuation or through transmission mode, a transmitter sends ultrasound to one surface and a separate receiver detects the amount that has reached in or another surface after traveling through the medium. Imperfection of other conditions in the space between the transmitter and receiver reduce the amount of sound transmitted, thus revealing the presence. Using the couplant increase the efficiency of the process by reducing the loss in the ultrasonic wave energy due to separation between the surface. Advantage and disadvantage ultrasonic testing. Advantage: ultrasonic testing is completely non-destructive. The test piece does not have to be cut, sectioned or exposed to damaging chemical. Access to only one side is required, unlike measurement in mechanical thickness tools like calipers and micrometers. There are no potential health hazards associated with ultrasonic testing. Unlike radiography, when a test has been properly set up, results are highly repeatable and reliable. Disadvantage: ultrasonic flaw detection requires a trained operator who can set up a test with the aid of appropriate reference standard and properly interpret the result. Inspection of some complex geometries may be challenging. Ultrasonic thickness gauge must be calibrated with respect to the material being measured, and application required a wide range of thickness measurement or measurement of equally diverse material may require multiple setup. Ultrasonic thickness gauge are expensive than mechanical measurement device. That's all from me about four methods of non-destructive testing. Thank you.